Hello everyone, welcome to the Chemical Safety Technology course. I am your instructor, Suo Yanbo. In this session, we will explore the fundamentals of combustion together. Combustion refers to an exothermic reaction between a combustible material and an oxidizing agent. It is a complex physico-chemical process characterized by three features: light emission, heat generation, and the formation of new substances. It is important to note that phenomena involving light and heat are not necessarily combustion. For example, an incandescent light bulb emits light and heat but does not produce new substances. Therefore, it is not combustion. The occurrence and progression of combustion require three essential conditions: a combustible material, an oxidizing agent, and an ignition source, commonly referred to as the three elements of combustion. All three conditions must be present simultaneously for combustion to occur. So, what is a combustible material? Any substance capable of undergoing a chemical reaction with oxygen in the air or other oxidizing agents is classified as a combustible material. There are many types of combustible materials which are categorized by physical state into solids, liquids, and gases, such as coal, wood, alcohol, gasoline, hydrogen, and methane. What is an oxidizing agent? Any substance with strong oxidizing power that can react chemically with a combustible material to cause combustion is called an oxidizing agent, such as oxygen, air, and chlorine. What is an ignition source? Any energy source capable of causing a combustible substance to burn is called an ignition source. Common ignition sources include open flames, impact from hot objects, and electrical sparks. Now that we understand the three elements of combustion, does their mere presence guarantee combustion? A combustible material, an oxidizing agent, and an ignition source are the necessary conditions for combustion. However, having all three elements present simultaneously and in sufficient quantities constitutes the sufficient condition for combustion. During the combustion process, changes in the quantities of these three elements can alter the combustion rate or even cause it to stop. This is the principle behind the various methods we use to extinguish fires. The combustion of combustible materials follows a specific process which varies depending on the state of the material. Gases burn most easily. They ignite rapidly once the heat required for their oxidation and decomposition is reached. The combustion of flammable liquids does not occur through a direct reaction between the liquid phase and air, but rather through evaporation into vapor, which then mixes with air to burn. For combustible solids, simple substances such as sulfur, phosphorus, and paraffin melt, evaporate, and mix with air to burn when heated. Complex substances such as coal, asphalt, and wood first decompose under heat to release combustible gases and vapors, which then mix with air to burn, leaving behind some solid residue. It can thus be seen that the combustion of the vast majority of combustible substances occurs in the gaseous state and produces a flame. Some combustible solids, such as coke, cannot transition into a gaseous state. They burn in a glowing state without producing a flame. In summary, based on the state of the combustible material during combustion, there are two types: gaseous phase and solid phase combustion. Gaseous phase combustion refers to a reaction in which both the combustible material and the oxidizing agent are gases. A characteristic of this type of combustion is the production of a flame. Gaseous phase combustion is the most fundamental form of combustion. Solid phase combustion refers to a reaction in which the combustible material is in a solid state. This is also known as surface combustion and is characterized by the absence of a flame, producing only light and heat, as seen in the combustion of coke. Some substances can undergo both gaseous phase and solid phase combustion, such as coal. Combustion can be classified from various perspectives, including cause-ignition method, sustained combustion form, fuel, state, and combustion phenomena. Based on the cause, combustion can be categorized into flash fire ignition and spontaneous combustion. The following sections explain these concepts in detail. A flash fire refers to the instantaneous, lasting less than 5 seconds combustion that occurs when the vapor of a flammable liquid, including the vapor of a sublimable solid, mixes with air and encounters an open flame. The lowest temperature at which a liquid can undergo a flash fire is called its flash point. A flash fire is often a precursor to ignition. The lower the flash point of a flammable liquid, the easier it is to ignite and the greater the fire hazard. In addition to flammable liquids, certain solids that can evaporate, such as paraffin, camphor, and naphthalene, can produce vapors on their surfaces that reach a certain concentration. When mixed with air, these vapors form flammable gas mixtures that can also undergo flash ignition upon contact with an open flame. Ignition is the sustained combustion of a combustible substance caused by an ignition source in the presence of sufficient oxidizing agents, such as oxygen, air, or chlorine. The lowest temperature at which a combustible substance will sustain combustion is called the fire point, or ignition point. The lower the fire point, the easier it is for the substance to ignite. The difference between the flash point and the fire point of a flammable liquid is that at the fire point, not only the vapor, but also the liquid itself, burns. Furthermore, at the flash point, the flash fire extinguishes immediately upon removal of the ignition source, whereas, at the fire point, combustion continues even after the ignition source is removed. Keeping the temperature of combustible materials below the fire point is one of the measures to prevent fires. At a fire scene, if two substances with different fire points are under the same conditions and exposed to a heat source, the substance with the lower fire point will ignite first. The principle behind extinguishing a fire using cooling methods is to lower the temperature of the burning substance below its fire point, thereby stopping the combustion. Spontaneous combustion refers to the phenomenon where a combustible material ignites and burns on its own due to heating without the need for an open flame. The auto-ignition temperature is the lowest temperature at which a combustible material will spontaneously ignite. Spontaneous combustion is divided into two categories: chemical spontaneous combustion and thermal spontaneous combustion. Chemical spontaneous combustion refers to the ignition of a substance at room temperature due to its own chemical reactions. Examples include matches igniting from friction and explosives detonating upon impact. Other examples include sodium spontaneously combusting in air and coal spontaneously combusting due to being piled too high. Thermal spontaneous combustion occurs when a mixture of a combustible substance and an oxidizing agent is uniformly preheated. As the temperature rises, the mixture will ignite automatically once it reaches a certain temperature. In this lesson, we have learned the basics of combustion, including the three elements of combustion, the necessary and sufficient conditions for combustion, and the types of combustion. That concludes this lesson. After class, please reflect on two questions. 1. What are the three elements of combustion? How do they relate to each other? 2. What are flash fire ignition and spontaneous combustion? What are the differences between them? Alright, that concludes this session. See you next time.